In this second video, we're going to be talking about powers of imaginary numbers as well as complex numbers. Let's go ahead and get started with the powers of I. If you remember from the last video, we said that I is the same as the square root of -1. And so what we can do is take I to different powers and get some simplified answers. If you remember from your exponents when you first started learning them, we always said anything to a 0 power will always equal 1. Well, the same thing applies in I. So I to the 0 power is the same as the number 1. That should be really easy to remember, same rule as any other exponent. If I take I to the first power, that's just the same as writing I. Okay. If I take I to the second power, I have to square it. So if I square -1, the square root of -1, sorry, the square root and the square cancel out, and we're left with the number -1. So I squared, if you ever see an I squared, that's the same as writing the number -1. Okay? And then lastly, I to the third is the same as writing I squared times I to the first. And we just said I squared was equal to -1. So I'm going to take that I squared and replace it with a -1. And then I to the first is just I. So if I multiply those together, we get that I to the third is the same as -I. So these four things here, 1, I, -1, and -I, are going to be the same four repeated answers that you would get no matter what your exponent is with I. You could have I to the 732nd, and it would end up with one of those four answers. And it's really nice because that pattern repeats over and over again. For example, if I move up to I to the fourth, that's the same as I squared times I squared. Well, if I replace I squareds with -1, then I get -1 times -1, which is +1. And now look, we're back to the beginning. That means I to the fifth should end up getting us I. Now we can double check that. I to the third times I squared, because 3 plus 2 is 5. That would simplify to -I times -1. And I got the -I from the I to the third here. So -I times -1 is +I, which matches this one, which means I to the sixth would have to be the same as I to the third times I to the third. So that would be the same as -I times -I. And when we multiply those together, we get +I squared, and I squared is the same as -1. So notice my pattern has just started to repeat, which now means if I said what's I to the seventh, we hopefully have caught on to the pattern. I to the seventh would be the same as I to the third, which is -I. And I could continue repeating this and it would get the same four answers. So let's use this concept to help us simplify some examples. In example 2, it says to simplify -5I times 3I. If I multiply those together, -5 times 3 is -15, and I times I is I squared. And we never want to leave i's with a higher exponent other than 1. So remember we said in that list over here that here's my four common solutions. So I squared is the same as -1. So I'd have -15 times -1, which is +15. And we're done. So never leave anything with a higher exponent than 1, because that means it could always be reduced. Okay. And example 3, here's a higher exponent. It says simplify I to the 31st. So that's obviously a very high exponent. We want to try to reduce it down. Now, when you have a high exponent like that, we've kind of got a trick to take this and figure out which one it matches. What you can do, since we have four options here, you could take the exponent 31 and divide it by 4. And again, the 4 because there are 4 different options. So if I divide 31 divided by 4, 4 goes into it 7 times. If I subtract, I get a remainder of 3. So the remainder is the important part. The remainder here tells you that I to the 31st is the same as I to the third. So notice that I've just carried that over. So I to the third we know is the same as -I. So the simplified version of I to the 31st is -I. And that's much easier to work with when you're dealing with the higher exponents. And you can do the same thing. I want you to go ahead and try I to the 55th power. So remember, you're going to take 55 divided by 4, figure out what your remainder is, and it should be 0, 1, 2, or 3. So it needs to match one of those 4 options. Once it matches one of those 4, you can reduce it down, and you're done. And if you have any questions on how to reduce those or where I got the numbers from the last page, please make sure you write yourself a note to ask me in class, and I can go through that with you individually. Now we can also use what we call complex numbers. Complex numbers have I in them, but they also have a real number portion. So all complex numbers have this form, a plus bi. You want to make sure you write this down. And the a portion is the real number. So I've got an example here, 5 plus 7i. Here is the real portion of it, and then here is the imaginary portion. So every complex number has those 2 parts. And these complex numbers can be used when we're talking about electrical type problems, where we're talking about impedance or current or voltage. And you might also see in those problems where they use the letter J instead of I. It's just a notation difference just to keep their letters separate, so don't let that confuse you. But for most of what we will use, you're going to see the letter I for the imaginary numbers. Okay, and you can do tons of things with complex numbers. You can add them, subtract them, multiply, and divide them. So in this video, we're going to practice adding and subtracting them. In the next video, you're going to see where we multiply and divide them. The other thing you might see is what we call pure imaginary numbers, and all a pure imaginary number is just a number with only the imaginary portion. So the real number would be like a 0, and that might be something like this, 5i, or you could have negative 2/3 I. All of those are pure imaginary because there is no real portion to it, just the imaginary portion. Let's jump into an example of adding and subtracting complex numbers. These are going to be really fast. When you add or subtract complex numbers, you basically have to think about combining like terms. So I've got here negative 6 plus 3i, that's one complex number, minus 18 plus 7i. And the easiest way to do this is to identify the real parts. So negative 6 and 18, I'm going to go ahead and subtract those. Negative 6 minus 18 is negative 24. And then I'm going to subtract the imaginary number parts together. So 3i minus 7i is negative 4i. And we're done. So add or subtract the real part, add or subtract the imaginary part, and then write it, make sure it's written in its standard form, and you're finished. I encourage you to go ahead and try this one. It's just an addition problem. Remember, adding the real parts and then adding the imaginary parts together, and then you would be done. The last thing in this section is where we will graph complex numbers, and again, very easy, very quick, just a little bit of a different notation. Remember, in the past when we've graphed things, we've always used X and Y for our axis. But now when we're talking about complex numbers, we have a different range of numbers to work with. So instead of calling our axis X and Y, we're going to call them the real axis and the imaginary axis, because we have 2 different parts to our number. So when you're graphing a complex number, you're going to treat the first number, the real number, like the numbers on your x-axis, and the imaginary part will be how much you go up or down. So in example 5, when I ask you to graph negative 6 plus 4i, the negative 6 being the real part tells you you're going to go left 6 from the center. So 1, 2, 3, 4, 5, 6. And then the 4i at the end is the imaginary part, so that means you're going to go up 4. 1, 2, 3, 4. And plot your point. So that point represents the complex number, negative 6 plus 4i. Okay. You could do the same thing if I asked you to graph maybe 2 minus 2i. So the 2 here would tell you to go to the right 2. The negative 2i would tell you to go down 2. And there would be your point represented on the graph. So just like plotting a point, but now we have the real axis and the imaginary axis. If you have any questions on those examples, again, feel free to ask me in class and I'll work through them with you. And make sure you watch the next video on multiplying and dividing complex numbers.